Good day, fellow engineers. Welcome to the ASTIG presentation by the Advocates of Structural Engineering Group, powered by the Philippine Group of the IABSE. Previously, Dr. Oretas already introduced to you the IABSE, or the International Association for Bridge and Structural Engineers. And today, I will discuss about the outstanding bridges previously awarded by the IABSE. The IABSE Outstanding Structure Award, or OSTrA, was established in 1998. Every year, IABSE chooses one of the nominees for Outstanding Structure Award, and this award is one of the highest distinctions given by IABSE. And the basis for determining which structure is to be considered as outstanding from all over the world should have the following criteria, or should pass the following criteria. One is for being most remarkable, for being innovative, for being creative or otherwise stimulating structure. Plus factor, of course, is its environmentally friendly design and sustainability. Okay, let's start naming these bridges. And the first on my line is the Gateshead Millenium Bridge of England. It is situated in northeastern England, and it bridges the gap between the Newcastle's North Bank and Gateshead Quays on the south. The Gateshead Millenium Bridge was constructed in the year 2000, thus making it the name Millennium, and was opened to the public in 2001. So what is the salient feature of this Millennium Bridge? It's an elegant bridge, or should I say an elegant curved pedestrian bridge for cyclist and pedestrian, with a unique concept of two interconnected arches which rotate to allow ship passage. Technically, this steel bridge is 205 meters long and made of a pair of steel arches. The pedestrian and cycle deck is an almost horizontal curve suspended above the river from a series of suspension cables. These suspension cables going to and from the arch and deck help to give stability for those crossing the bridge. The bridge tilts as a single rigid structure. As the arch lowers, the pathway rises, each counterbalancing the other. This ensures a minimum amount of energy used during its lift. The pedestrian deck is about a foot higher than the cycleway to provide clear views of the river and to allow a higher safety guard to be used for cyclists. And when the bridge open and close, it takes only about 4.5 minutes to do so. Our next bridge in line is the so-called three countries, or the tri-countries bridge that can be found in the tri-boundary of Germany, France, and Switzerland. This bridge, located in the border triangle of southwest Germany, crosses the Rhine River near Basel and was opened in March of 2007. The bridge near the border to Switzerland majorly improves the infrastructure in the region and connects Germany and France. And as you can see, this 2009 awardee has a deck length of 229 meters, the world's largest so far when it comes to pedestrian bridges. And the steel arch bridge support has a total length of 248 meters and is only about 20 meters high, and the highest point is about 25 meters from the water. The bridge deck is about 14 meters below the arc crown. And if you will take a look at the cross section, the supporting structure is asymmetric. On the upriver side is a hexagonal cross section of sheet steel, and downstream are two others. The first is more inclined to the inside, and the latter two are bearing the brunt of the load. So the arches are built with cast steel nodes to avoid gusset plates. So as you can see, it is a very clear finished arch. And the arch was made asymmetric due to the malleability of the material, the steel. Okay, let's move forward. And our third in line is the Taizhou Bridge of China, which was selected as the Outstanding Structure awardee for 2014. This 2014 IABSE awardee was notably a different one, and it made the impression of having a breakthrough in engineering and construction to span over large distances. That this bridge ushers in a new generation of multiple long-span continuous suspension bridge. Of course, this is located in the Jiangsu province, connecting across the Yangtze River in the Yangtze Delta region. So it is the first ever long-span three-pylon in the history of bridge engineering. So, as you can see from your screens, this spectacular suspension bridge has two continuous 1,080-meter main spans, and it carries dual 6 traffic lanes with a deck width of 34.8 meters. The central pylon, which is an inverted Y shape, stands 200 meters tall, constructed in steel and founded on a 58-meter by 44-meter caisson. The pylons at each end of the main bridge spans are concrete frame structures 180 meters tall, and each founded on 46 pieces of 2.8-meter diameter friction pole. This bridge also qualified for its environmental construction by minimizing the ecological impact on the environment and minimizing impact on the river hydraulics and ecology through reducing or reduction of the number of bridge piers in the water, while providing for two main navigation channels to facilitate ship movement and encourage the development of port facilities within the region. So this scheme was also cost competitive given the site constraint and project conditions. So if you can see, the central pylon on the left represents a Chinese character referring to as a human. So on the other side is the method of construction, the segmental construction of streamlined steel box girder. So the steel box girder is very efficient. Okay, so how are you so far? Our next in line is the San Francisco Oakland Bay Bridge, new east span in the United States of America, and it was the OSTrA 2015 recipient. Okay, this one is a hard, or should I say, breathtaking bridge design, because this regional lifeline structure is located between two faults, the San Andreas and the Hayward faults, which are known to be destructive faults. It crosses the San Francisco Bay east of Yerba Buena Island, and it is a single tower, self-anchor suspension bridge. With the innovations in design, it earned the impression that advanced or groundbreaking advanced bridge design of the San Francisco Oakland Bay Bridge demonstrates how innovations in seismic engineering can become the bridge to making history. Technically speaking, it has world records for being the longest single tower, self-anchored suspension bridge with a total length of 3.5 kilometers, and currently the widest bridge in the world, according to Guinness, with 78.74 meter width. In terms of height, it's only 160 meters, but carries 10 general purpose lanes and expected to last at least 150 years. A replacement span designed to withstand largest earthquake and carry emergency traffic. This bridge also differs in terms of highlights. The highlights of constructions involve cable assembly, installation of hinge pipe beams in skyway segment, and it also features engineering innovations and advancements, including shear link beams in the single tower, hinge pipe beams, and specially designed expansion joints in the bridge decks, and foundations that reach up to 91 meters below the water surface to anchor in stable soil. It is referred to as a dramatic signature bridge. Has been designed to save lives while enhancing the Bay Area of the United States. Also, it was a finalist for the Outstanding Civil Engineering Achievement Award given by the American Society of Civil Engineers. And finally, our last in line is the 2018 awardee, the Yavuz Sultan Selim Bridge of Turkey. This Sultan Selim Bridge, made of steel, is an iconic structure and a new landmark of Istanbul and Turkey, linking Asia and Europe. It is a suspension bridge with cable stays used as a motorway or a freeway with a railroad. In terms of world record, it is the second tallest bridge at 322 meters for its type and one of the world's widest suspension bridges at 58.4 meters. So this is a combined road rail bridge, as I mentioned earlier, and carries 4 motorway lanes and 1 railway in each direction. And what is so amazing is that it was finished in just 3 years period. Freycinet was responsible for the studies, design, supply, and installation of the record-setting structures, cables, and dampers. It also handled the structure's pre-stressing and lifted the 17 central span segments. On your screen, you can see the horizontal or the longitudinal cross-section showing the height and the length of the bridge and its components. And on this particular slide, showing the cross-section of the deck, that shows also the motorway, the location of the railway, and all the details of the slab deck. So you can see that it's very lightweight and adequately designed, complete with dampers and cables. So that's all, guys. Thank you for watching, and if you have any comments or suggestion, please like this video, and if you want to share, you can share it and give us your feedback. Thank you very much for watching, and I hope you'll stay astig forever.